Hey guys, Rudi back with part two of the week 8 CSSE1001 Python tutorial, or my solutions to it anyway. So we're going to be looking at the web crawling section, right? If you're after this first half, extending students and a general sort of explanation of classes and inheritance, check out the part 1 video. But for now, we're just going to dive straight into the web crawling exercise. So we've just got a bit of context here. Building a search engine, you need to start by having a list of all the web pages on the internet. The simple way to find web pages is to start with a known web page and follow all the links to different pages, repeating that, looping out until you basically web out like a spider web and find all the links to all the pages in the world. Okay, so what we're going to do here is we're actually going to write a program which takes a URL for a web page and finds all the links on that page. To do this, we're going to need to learn a bit about HTML and the Python class HTML parser. Okay, so what's HTML? HTML, I think it's hypertext markup language, something like that. Basically, is the language or sort of templating language that most web pages are written in. Okay, so you've actually probably seen this somewhere before when you've gone to the inspect source or view page source or something like that. So we're actually going to check out the view page source here, and I'm actually going to bring this up alongside just so we can have a bit of a look. So the gist of HTML, right, is we have all these things here called tags. Okay, so you see we've got the less than and then the greater than sign to sort of as an open and closed bracket. This thing here is called a tag. So for instance, this is called a P tag, right? And the P tag stands for paragraph. So if we actually look here, we can see in last week's tutorial we wrote we've got another tag here, code, and the close tag for code. That's what that backslash is. And we can see that that's this section here. We wrote a student class. We see the stuff inside the code tag student looks slightly different. It looks all codey. We keep going down. We can see there's another paragraph tag we would like to extend. Let's say our paragraph here. Then we've got a UL. That's an unordered list, so dot points, right? Not 1, 2, 3, just plain dot points. That's what's happening here. And yeah, so that's sort of the general gist of HTML. Really, it's just a whole bunch of sections or divisions that we specify with these tags, and then we put our text inside there, and we basically allows us to structure how the web page will look, and then we can sort of style that later on using some other stuff. CSS is another language you could look up, and JavaScript are the main things we use in web design. If you're doing Deco 1400, that gets covered in that course, or if you're thinking about doing Deco 1400, that's basically the basics of web design stuff. But basically, what were we looking for? We were looking for all the links on the page. So let's actually go and find a link here. Web crawling. This method is called web crawling. So here we've got a link. So let's go to where that section is. Web crawling. See, this is in a header 2 tag, or size 2 header. And we can see, cool, here is our link here. And what's it in? It's in an A tag, right? Because we hear the name. Here's the name of the tag is A. It's an A tag. And we can see on the inside of this opening tag, so there's the corresponding close tag there, the A, web crawling. We can see that our link is called web crawling. But we can see inside this opening tag, we've got all these something equals something. Now these are called attributes of the tag, right? So the A tag has a target attribute here, and it has an href attribute here. I think the target attribute is what it determines whether it opens in a new page or on a new Chrome, or if it just opens on this page, stuff like that. We're not interested in that though. What we're interested in is this guy. So the href attribute and its value is what determines where this link actually goes, right? So if we actually try and open this guy, you can see we've gone to Wikipedia web crawler, right? So what we want to do, sort of ultimately, is we want to write some program that can go through all this HTML on a page and find all the A tags and find all the href values inside that A tag. That's pretty much what we want to be doing here, right? Now, there's a whole bunch of different text in here and a whole bunch of different things, and we could try going through it line by line and sort of agonizingly working out all the edge cases and what to look there. Or, better idea, we could use this Python HTML parser. We've got some context here, right? Python, in the standard Python library, right, contains a library called HTML parser, which can help interpret HTML text. So someone's already done all that line by line agonizing edge case searching for us, okay? The HTML parser class has a method feed, which takes a string. For each HTML tag within that string, the class calls its own handle start tag method. Okay, so basically, if we have a class, right? I'm actually going to close this down and start looking at the example code here. copy paste this in. The parser class has a method feed. For each HTML tag within that string, the class calls its own handle start tag method. Okay, cool. So we pasted this code in here. This is the code we got given just in this box. So we've seen we've done a whole bunch of importing stuff. So we now have access to the HTML parser library. We now have access to these also URL libraries. So that'll allow us to do some file stuff. So let's see what we've got here. Open the web page, read the HTML text. So this is, if we go find links, we want to open a URL. We want to get the text out of that by reading it. And then we want to have this text variable. And then what are we doing down here? We are setting up an instance of a link parser class. So we still need to make that class. So that's actually what we'll be doing. And then we're calling its feed method with that text we've been given. Okay, cool. So let's actually have a look at what the first task is. Make the following modifications to this code. Write a class link parser which inherits from HTML parser, and write a method handle start tag which prints out the two parameters tag and attributes. So let's get into that. So we want to make a class called link parser, and we want it to inherit from HTML parser, right? Which is that Python standard stuff we already imported up here. Cool. And write a method handle start tag. Oops, forgot my def. Handle start tag, which looks like it takes self, tag, and attributes, which prints out the two parameters tag and attributes. Okay, that's pretty straightforward. Print. Yeah, let's print tag and attributes. I'm actually going to try and let's actually make this a bit more explicit so we can see what's happening. Tag attributes. So remember that the tag was that thing inside these guys. So like the A tag or the P tag, and the attributes were the things inside there. So how we could set href to be like Google. Stuff like that, right? So remember, A was the tag, attributes were these guys in HTML terminology. Okay, so we've done that. So let's actually have if we have a bit of a read over what we were saying before, right? The parser class, right? This HTML parser class we're inheriting from. We've essentially almost got an HTML parser class. The only difference is we've put this method in here, handle start tag. Okay, so otherwise, for all intents and purposes, this is just a plain HTML parser. So what does it say here? The HTML parser class has a method feed, which takes a string. For each HTML tag within that string, the class calls its own handle start tag method. Okay, so by default, HTML parser, when we call this feed here with some HTML text, every time it finds the start of a tag, every time it finds a tag within the string, it calls handle start tag. So what are we doing here? We're actually overriding the handle start tag method from HTML parser. So even though in the rest of the code, HTML parser is going to be calling handle start tag, we've sort of intercepted that, and we're just saying, cool, whenever you call handle start tag, let's just print stuff. Let's just have a look at what's happening. Okay, so let me move that over. And now let's try calling find. Oh, actually, I don't have a web page. I'm sure there's one in the actual example down here. Yep. Cool. So find links. Here we go. Find links. Let's go make it here. Get the shell up, and let's call find links with this URL. Oh, that's a whole bunch of red. 404 not found. Oh yeah. Okay. There we go. Sorry, that was the old name for our website. .html. Get rid of that. Let's just put in week 8. Oh no, what did I press? Oh my, oh god, I've copy pasted something. Ugh, get rid of that, enter. Oh, okay, there we go. That's what I was hoping would happen. So we've printed out a whole bunch of lines, right? Because we basically went through that big HTML page of the website that I had opened before. And it went, cool, every time we find the start of a tag, give out a tag and give its attributes. So let's actually have a look at what we've got here. We've got a tag. With all those nice p tags and stuff we had at the start. Ooh. Okay, well, here's a link. Here's a link tag. Let's look at this. So we found an A tag, right? The tag was A, and then let's see what attributes it had. And what have we got here? This looks like, I've got the square brackets, right? So this is a list. Okay, and what's each element inside the list? It looks like we got the curly brackets, right? So this is a tuple. This is a list of tuples, and each tuple has two things inside. Okay, so here we've got the href and the value of that link, and here we've got target and the link. Okay, cool. So it seems like when we print tag and attributes, tag gives us just the single character. So A or LI, or I'm sure there'll be P tags or UL tags somewhere else in here. And attributes gives us a list of tuples of the attribute and their value. Okay. Yep, sweet. So we see we've also got some code tags and some P tags that had no attributes. So let's leave that for now. Let's see what else we're supposed to be doing here. Number 2, modify the handle start tag method to print out the href attribute of every link tag within the HTML text. Okay, so we sort of started just by printing everything, right? Now we want to be a bit more specific. We want to first be like, oh cool, where are all the link tags only? Let's actually start by only printing the link tags. So as opposed to printing all this every time, let's write an if and be a bit more selective, right? Let's try and filter this down. Okay, now we only want to print links, right? So like what I had before, a link is what? It's an A tag, right? It was just the character A. So we'll basically say, well, if the tag is the character A, then let's print it out. So let's see what that does. Let's see if that works. Find links, get rid of the HTML. Okay, cool. So we've got a whole bunch less now, and it's only printing out the A tags now. So we see pretty much all of these have this href, right? Because there's no point having a link without somewhere to go. And just something interesting, you'll notice that some of these are HTTP links. So that's sort of like an external link, right? It's taking us away somewhere to UQ or taking us out to, I think one of them had Wikipedia before, Python docs, W3 schools, right? But some of these are just slash assignments or slash MPT problems, right? So this is a local link. This basically is saying, oh, it's linking to within our own website, right? Because if we bring up the page again, right, slash tutorials slash week 8. So if we go to just slash assignments, for instance, we can see that this takes us to our internal page. So that's how those links are working, if anyone was curious about that. But for now, we wanted to print not the entire A tag and all this sort of mumbo jumbo. We only wanted to print the href attributes. Okay, so once again, we can see that we're getting this list of tuples, and they're paired tuples, right? It's the attribute and its value. So we can actually abuse that structure to make our search really powerful. So if the tag is an A tag, well, what do we want to do? I'm actually going to stop printing this for the moment. So if the tag is an A tag, now we only want to look for the href attribute. Now, since we've got a list, right, and we basically want to search through that list, let's start off with a for loop. So for what are we looking for here? I'm actually going to move a bit more space. For atta in atters. No, not in atters. What am I doing? Tag. Oh yeah, sorry. Yeah, no, exactly. For atta in atters, right? Let's just print atta. And let's see what we're getting here. Okay, so we can see that it's no longer printing the A, right? And it's printing out every single attribute with its corresponding value. So we've got a whole bunch of hrefs and the occasional target and that sort of thing. So that's good. Now we only want to print out these ones when there's an href tag. Okay, so we can narrow this down even more. We can get the value and this. So since it's a pair, actually, I'm gonna try and be a bit tricky here. We've got the attribute, but we can also print the attribute and the value. Right? So we could get attribute out, right? We could do something like this. Get attribute out and then try and split it up using this notation, right? But I'm actually going to try and unpack it. So remember tuple unpacking. I'm going to try and unpack it in one go, the attribute and the value. So let's print out the attribute and its corresponding value. Cool. So we see we've separated them out of that tuple now. So well, now this is a fairly easy sort of problem to solve, right? Because we basically wanted, well, we only want the attributes that are href. So let's just do another check. If attr equals href. Forgot to close my string. Now, what did we actually want to do? Print out the href of every attribute. Cool. Then we just want to print the value. And let's, oh, I gotta stop closing this. Cool, see, we're getting only the links now. So we're pretty close now, right? We're just getting all these links. So great. What's step 3? Modify the class so that it stores a list of URLs, and modify the handle start tag method so that it adds the linked URLs into the list. Okay, so we wanna make our class store a list of URLs. Right, so that sounds like we need a self attribute. We need some sort of list that belongs to the actual instance of the class. So we would want to set that up initially in our when we make the class, right? But we haven't actually defined an init method yet. So it looks like we're going to have to overwrite the init method here. Okay, so what did we make our init method with? We only made our init method with nothing actually. We just called link parser and passed nothing through. Cool, so okay, well let's just override our inner method then. Now, since we're overriding a class that we don't know too much about, this HTML parser class, we probably want to call the super init method here, right? Because we want to start by making an HTML parser, and then we want to customize it by adding our own stuff. So if we remember from part 1, to access that super class, we've got that super init. And we don't actually have to pass in self again because super does that for you, right? If there's still confusion about this, check out part 1 again. But yeah, we want to make sure that our link parser is this kind of HTML parser. We don't really know what's happening there, so we're just going to play it safe and go, well, whatever you did with an HTML parser, do it when you make a link parser. But we also wanted to add a list to store URLs. So let's add a URLs, and we'll make that empty at the start, right? Because we haven't found anything yet. So when we make our thing, we're making an HTML parser. We make our when we make our link parser, that is, we make an HTML parser, and then we also just tack on a little extra list. So it's almost the same thing, but we've just added a bit more for us, right? We've inherited and sort of used that to our advantage. Now, what we want to do is modify the handle start tag method so that it adds the linked URLs into that list. Okay, so instead of just printing these out now, we want to add them into our list. So if you remember, adding to a list is append. So let's go self._URLs. Wasn't really high there. I don't know why. Self._URLs dot append value. Cool. So now we've added this into our self.URLs, and so that means every time we have this link parser, every time we run through handle start tag and find an appropriate link, we're going to chuck it into our self.URLs. So our URLs is actually going to build up as we go, which is what we want, right? Because if we wanted to build a whole list before, we couldn't just build a list inside this tag, right? Like we couldn't do a something like this. URLs takes on this and then trying to add to just URLs. Because what's going to happen is we call this function like hundreds of times, right? And every single time we call this function, we would overwrite this variable. And so we would only ever return one element in a list at a time, right? And that's not what we wanted. We wanted a complete list. So that's why we're going to use this self thing here, right? It's very important if you think about how the assignment works, right? This is an important concept to think about when you need just a local little variable to do one little thing, or when you need to constantly, not constantly, but when you need to sort of persist that data, when you need to store it for future use, because that's when you want to use a class self variable. Okay, so what else we got here? Add a method get URLs which returns this list. Okay, well that's some standard getter stuff. Def get URLs self, and we just want to return that list of URLs that we created. That's pretty straightforward. And use that method in the return value of find links. Find links. Was that function we wrote? Okay, cool. That was our function, find links. Write a return statement here. Okay, awesome. What was it? Return get URLs. Return. Okay, so get URLs is a method of our link parser. We made our link parser here, so let's call that guy's get URLs method. Sort of just to reiterate, we made a link parser. We called that feed method. The feed method was the thing that runs over all that text in the code. sorry, all that text in the text variable, I guess, does all this handling start tag stuff, right? Which is now going to build up our list of URLs. And then we're just calling the parser.urls method, right? Which now should hopefully return that list that we spent all that time building up when we ran the feed method. So you can see how this self.urls variable is persisting, right? It's created here, it's updated here, right, through this parser class, and then we should be getting it back out here. So let's try running that. Great. We see we've got this list. We've got a nice list with all these different links in it, and we could now iterate through that list however we wanted, however we needed to, because we have a list is a nice structure to go through, right? We can go through all those links, and say we wanted to keep web crawling, right? We could, at this point here, when we've got these URLs, right? We could return these URLs, or we could even use these URLs. I'm not going to get rid of that. We could even use these URLs to open up more web pages and do the same thing again, right? And we can we could run that forever and continually try and get all the links on one page, go to all of those links, get all the links on those pages, and that's sort of how this web crawling concept would occur. Okay, so this is another powerful way of using inheritance, right? Is when we've got someone else's code and they are happy for us to use it, and it's perfectly legal, and they want us to use it, and we're not stealing anything. Don't steal code, guys, it's not cool. But when we've got this open source code that we can use, we can actually extend it, slightly modify it, and sort of tailor fit it to our own needs here, right? Because we saved all this time of going through all that text and searching for starts with and ends with tags and all that sort of stuff. We basically just cut all of that, and we're still able to just use this other class to get what we wanted done, right? We managed to search through the whole thing and get it working. Yeah, and there's our executed code there. So that's pretty much what we got working. Okay, awesome. So that's pretty much the end of the tutorial. Once again, you got any questions, chuck them in the comments, chuck them on Piazza. I'll try and get back to you if there are any questions about what's going on here, or if you got any comments on the two-part video, or if you prefer the style, great, let me know. Otherwise, I'll see you guys next week.